quantitative literacy. These are the notes for 12.1 and 12.2. Chapter 12 deals with statistics, which logically comes right after probability usually. These first two sections we're basically looking at how to display data and then looking at measures of center, which we'll talk about in a second. So this first part deals with making a frequency distribution along with a histogram and frequency polygon. And we're going to use number 1 to do all these things. So for number 1, we've got 40 students were selected and they were asked how many hours they spent studying in the week. So we have a variety of solutions or answers here. It says to use 7 classes of uniform width of 10 hours. Okay, 7 classes. So basically the classes are going to be the low and the high end for a group. And you'll see what I mean as we start to calculate these. What I want to first figure out though is what is my lowest amount of hours studying? What's my smallest number in the table? And my biggest number. The smallest is 12. And the biggest is 72. So to build my class limits, I basically want to make sure that I start below the minimum value. Since I'm doing increments that are 10 hours, I'm going to go with a multiple of 10 for my starting one, and I'm just going to start with the number 10. So that's going to be the low end. Now, if I want it to have a width of 10 hours, you've got to be careful here. I'm going to go from 10 to 19 hours. You got to be careful there because people would think 10 to 20, but it's actually 10 to 19 because if you think 10, 11, 12, 13, so on and so forth, all the way to 19, that actually would be 10 numbers because I'm starting at 1, 0 and going to 1, 9. That means that my next class is going to be from 20 to 29, 30 to 39, and so on and so forth. 40 to 49, 50 to 59, and the last one will be 70 to 79. Let me get this down here. So basically, all this fancy stuff, class limits, frequency distribution, all of this is basically saying count how many data values are between 10 and 19. So I'm just going to look through my chart and count. So 1, 2, 3, 4, 5, 6. So there were 6 values between 10 and 19. So now I move down to the 20 to 29 and I count how many are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you get the idea here. I'm just counting how many are in each group. That should be a 9. Let's try that again. And basically, I'm going to do that for each group. 30 to 39, if you count, there are 12 values. Then there's 6 in the next group, 4, 2, 1. Now, it is also a good idea to make sure that your total amounts add up to what it's supposed to be. It said, I believe, 40 students. So if you add up the 6, 9, 12, 6, 4, 2, 1, they should add up to 40. Now on the next part, it also wants the relative frequency. This is basically the percentage of total. So the relative frequency is going to be a percentage. So basically you just have to figure out what 6 of 40 is as a percentage. So you could divide that in your calculator. That would give you 0.15. Move the decimal place over twice. And you got 15%. Then I would do the same thing with the 9. 9 out of 40, that gives me 0.225. Move the decimal place over twice, and I've got 22.5%. And I would just keep doing that with all the numbers. 12 out of 40, 6 out of 40, so on and so forth, and you'll get the corresponding percentages. Now, just like the frequencies should have added up to 40, the relative frequencies should add up to 100%. And if you check that, they do. Okay, so we've got our data, but now we want to display it in a histogram. A histogram is essentially a bar chart or a bar graph. My vertical axis on a histogram is always the frequencies. So that's going to be F. My horizontal axis for this problem is going to be the hours studying. I'm going to have to zoom in here so we can actually see what I'm drawing here. So this is going to be my hours studying. And basically for each mark on the x-axis on the horizontal, I'm just going to use those class minimum numbers. I had 10, 20, 30, etc. So the last one would be 80. For the frequencies, I decided to just make these go by 2 because the biggest one I had was 12. And if I go by 2s, starting with 0, that gets me up to there. So basically, I'm just going to make little bars for each class. So the first class that I had 6 for a frequency. So I'm just going to make a bar between the 10 and 20 up at 6. And then 20 to 30 went to 9. So that'll be between the 8 and 10. Then it went up to 12. Again, I'm just kind of eyeballing this. Doesn't have to be perfect right now. Then back down to 6. Then down to 4. 2. And for the final class, only had 1 value in it. So 1. I'll make that actually a little smaller. Something kind of like that. So that's all the histogram is just a bar that's at the height of the frequency. Now to go from a histogram, the bar graph, to a frequency polygon, I'm going to basically have the exact same numbers for the frequencies. So on the vertical, I'm still going to go with the 0. Oops. Zoom it back in here. I'm going to go with 0, 2, 4, 6, 8, 10, 12, 14. But for the horizontal axis now, the frequency polygon uses the midpoints of each class. So here's what it means. My first class was 10 to 19. The midpoint of that, well, the middle is just the average. So if you averaged 10 plus 19 is 29, and divide that by 2, that gives you 14.5. So that's going to be my first class midpoint. I'll do the same thing with the 20 to 29. I'll add them up. That's It's 49. I'll divide that by 2. That'll give me 24.5. I'm going to basically be increasing by 10 from each one. So what does this mean? This means that for my frequency polygon, I'm going to go just basically, oops, that's not what I wanted. I'm going to go in the middle of each one of these lines and put my class midpoint. So 14.5, 24.5, so on and so forth. 34.5, 44.5, 54.5, 64.5, and 74.5. And now instead of doing bars, I'm just going to do dots above those for how big they were. So the first class was at 6. So at 14.5, I'm at 6. 24.5, I was up at 9. 34.5, I was at 12. 44.5, I was back down to 6. And then down to 4. And down to 2. And 1. And to complete this, I connect the dots. And with a frequency polygon, you also shoot it back down to the x-axis. So 2 ways, really, of displaying the exact same data. A histogram does it in bar form. A frequency polygon does it with these little dots connected, but they still represent the exact same numbers. 6 high, 9 high, 12 high, etc. On number 2, we are using a histogram to answer these questions. So, how many people have heights between 149 and 179? So it's basically saying between 149 and 179, how many people? Well, I just got to take the heights of these bars. This one is 9, this one's 7, this one is 5, and just add those together. So that'll give me the total amount of people in those heights, which would be 21. For letter B, how many are under 169.5? So I'm going at the 169.5 and just counting everything less than that. That's going to be a 6 plus a 9 plus a 7, which is 22. Letter C is a bit of a trick question. How many people are 173 centimeters? Well, I know that's in here somewhere, between 169.5 and 179.5. But all this tells me is that there's 5 people in this range of heights. I don't know if any of them are 173. So this actually, I cannot tell. And that's a disadvantage to a histogram, is that you know how many are in the group, but you don't know their individual numbers. Letter D sounds like it would be the same answer, but it's actually a little tricky as well. How many people are 135? Well, 135 is smaller than 139. There's nothing over here. So we definitely know that nobody is 135 centimeters. Okay, that does it for the first video. We'll do the back side of these notes on the second video.